So the Cartesian coordinates right-handed axis system can help for guidance when you are creating, moving, rotating vectors in Maya. So I don't have a right-handed modeling here. So I'm gonna explain creating simple vectors. Sorry. So the first one is gonna be the first vector is gonna be the thumb. So the thumb is always pointing to the y-axis. So here, let's put here. So thumb will be pointing to the positive y-axis. Let's back here. No. Yeah. The second one is gonna be the middle finger, and the middle finger will be pointing to the x-axis. But here, middle finger will be pointing to the x-axis. And the third and last one, it's gonna be the forefinger, and the forefinger will be pointing to the z-axis. Let's put here. Forefinger will be pointing to the z-axis. So the right-handed axis system, it's a way to visualize the direction of the vectors. So, and it's really handy when you are working on Maya. For example, let's create here simple cube. So let me here. Cool. So let's move here just to centralize better. Now, see here. So, for example, here we can see this edge. It's pointing to the y-axis. This one to the z-axis. This one to the x-axis, and this is really helpful when you are modeling or animating and you need guidance, and you can, for example, move the object in the x-axis. No, sorry. You can move here the object, in this case a cube, in the x-axis positive or negative, in the z positive or negative, and the y positive or negative. It's a really handy way to visualize the direction of the vectors, and you can rotating as well. So that's why we use the right hand axis system in Maya. So now I'm going to talk about how to add and subtract vectors. So the rule to addition, vector addition, is vector addition is commutative. So vector A plus vector B, it's equal to vector B plus vector A. Okay, so let's do here. So the first vector, it's gonna be the vector A. So let's put here. This is gonna be the vector A. Let's put 3. Yeah, it's better to visualize. Okay, so this is gonna be the vector E. And now let's make the vector B. Here, 3. Perfect. So now the addition of the vector A, this is like the vector A, let's put here just 2. A. It's not working. Okay, not working. And here, vector B. So this is the tail of the vector A, and this is the head of vector A. This is the tail of vector B, and this is the head of vector B. So the addition of vector A plus vector B will create another vector that I'm going to call as vector C. Okay. So vector A plus vector B is going to create a third vector that I'm called by vector C. Now we are going to do the subtraction of vectors. Let's just delete this and all of these that I don't know how to, oh, here, yes. So now we're going to create the same one, the vector A, the vector B, so here is the tail of vector A, head of vector A, tail of vector B, head of vector B. When you subtract, the third vector is gonna be created by the tail of vector A. So here I have the third vector, and so I can multiply the vectors and move. Okay, I can subtract vectors. I can move. And I just forgot to say that the rule for subtraction is different of the addition one, and so the subtraction, it's vector subtraction is not commutative. So A minus B is different of B minus A. So what is a unit vector? The unit vector is a vector which has a magnitude of 1. So let's suppose this is a whole vector with the name is, let's call A. Okay, so this is the vector A, and the vector, the unit vector would be just this part of the vector. And to find a unit vector, first you need to find the magnitude of the vector And after that, you have another expression to find the unit vector. In the next video, I'm gonna show how to find the magnitude of the vector. So now I'm gonna talk about how to find the length of a vector, the magnitude of a vector. So here we have the vector A. Okay, and let's suppose that the vector A, I don't know what's happening here. Vector A is equal 3, 4, and 0. So to find the square root, I'm gonna try to use the pen with my mouse because my dog ate my digital pen a month ago. So I'm gonna try to use with this, with the mouse. So the expression to find the length of the vector, the magnitude of the vector, would be like the vector A, okay, is equal 3, 4, and 0. So to find the length to be the square root of x to the power of 2 plus y to the power of 2 plus z to the power of 2. So let's go there. I think if I change here, it's gonna be easier, isn't it? I think so. Let's put here. So it's gonna be 3 plus 4 plus 0. Just let me put the powers here, the power of 2, 4 to the power of 2, and 0 to the power of 2. That the result is gonna be the square root of 25 that's gonna be equal to 5. So this is the length of the vector 5. That's the way to find the length of a full vector. So now what I'm going to do is to find the dot product. So let me make vector here. This is gonna be the vector A, and let's make another vector here. Sorry, that's gonna make another vector here. This is gonna be the vector B. Vector A. Vector B. Okay, so the dot product is the projection of vector A on vector B. So let me show you here. This will be, this is gonna be like the dot product here. It's just an example. Okay, now I'm gonna show you how to find the dot product. Let's do Word again. I have some things that, let's open a new page. I don't know, this is here. Okay, okay, I think this is better. So let's suppose I have vector A, it's equal one, two, three. This is the coordinates for vector A. And these are from vector B. So to find the dot product, it's vector A and B, dot product of vector A and B, it's equal the length of vector A and vector B, and let's see now. Yeah, so here we can make it better like that. Isn't it? So let's go. So to find that product first, I'm gonna be here. A is square root of 1 to the power of 2 plus 2 to the power of 2 and 3 to the power of 2. That's equal 3.74. Okay, now we have to find the end of vector b. That's gonna be square root of -2 to the power of 2 plus 0 to the power of 2 plus 5 to the power of 2. That's equal 458. Okay, so now are we going to find the dot product? So it's length of A the length of B cosine sin beta is equal 1 multiplied by -2 plus 2 multiply 0 plus multiply 0 plus 3 multiply or 5. It's gonna be 13. Okay, so three 7 4 multiply for 458 multiply cosine that equal 13. Okay, so cosine that equal 13 divided for 374 multiply for 458. It's gonna be 0, 7, 5, 8. Now here that equal cosine to the power of -1 0.758. That's gonna be 40.71 degrees. This is the dot product. That's how we find the dot product. I'm sorry for the mess, but how did I say before? Like, I lost my digital pen, and so I'm doing this with my mouse, and it's very difficult.